Hi folks, welcome to 4.1 Antiderivatives. So today we're going to talk about the opposite of derivatives, thus antiderivatives. So let's take a look at these four examples. And the question I have for you is, where did these derivatives come from? So if we have dy dx equals 2, then we can say that it maybe came from 2x, because when I use the power rule for 2x, I get 2. If I think about where dy dx equals 1 over x comes from, I might remember that the derivative of the natural log of x is 1 over x. And if I look at dy dx equals 3x squared, I might think, okay, well, maybe that comes from x cubed, because I could bring the power down, which gets me the 3, and then when I lose a power, 3 minus 1 gives me 2. And last but not least, where did the dy dx equals cosine x come from? Well, if we start with sine x, we'll end up with cosine x when we take that derivative. Okay. So, an antiderivative is asking us this question. If we have a derivative, how can we determine what function it came from? And it turns out that a function, capital F, and that part is important here, we're going to use capital F to talk about an antiderivative. So if a function, f, is an antiderivative of the function little f, if the derivative of the antiderivative is the function. Let me write that out in words. So this part is saying the derivative of the antiderivative equals the original function. Okay, and this is going to be true for all x that are in the original domain of the function. So, given a function little f, the indefinite integral has a special symbol, and it's this symbol right here. I kind of write mine like an F, but without the little line. You'll find your own way of writing it. But that's the symbol that tells you about the indefinite integral. Now you're also going to need, not the comma, but the dx at the end. So together, these two things tell you to find the indefinite integral. And the most general one is when we have this plus c at the end. So the expression f of x, this part, is called the integrand, and the variable x and x and x, that is our variable of integration. So some of you might be wondering, what does this plus c at the end mean? And do I really have to put it? So the answer to that second question is yes. Yes, you need to put that plus c there, and let's talk about why. So if I have dy dx equals 3x squared, maybe it came from y equals x cubed, right? If I use my power rule, I bring the 3 down, and then 3 minus 1 gives me 2. But maybe it came from y equals x cubed plus 10. If I take that derivative, the x cubed part will get me the 3x squared, but this 10 at the end is going to go to 0. Or maybe we had y equals x cubed minus 11 over 2. And same thing, that derivative of 11 over 2 is going to go to 0, so it won't show up in my derivative. Okay, well, let's see where 1 over x came from. we know it comes from natural log x, but maybe it came from natural log x plus pi, or maybe it came from natural log of x minus 2.7. I don't know. But either way, this plus pi or this minus 2.7, that is something that we consider a plus c, some sort of constant. And let's just take a look at this last one here. dy dx equals cosine x. And we know that comes from y equals sine x. Or maybe it came from sine x plus 1.05. Or maybe it came from y equals sine x minus e. E is also a constant. So this plus 1.05 and this minus e, those are all the plus c's that we talk about when we look at this formula. Okay. So here's what questions will typically look like. You might have a question that says, find the antiderivative. So this squiggly sign and the dx mean find the antiderivative of the function that they give you there. And so we know that 3x squared comes from x cubed, so we can say this equals x cubed plus a capital C. Now, I'm going to write all the C's as a capital only because WebAssign does that. Normally, I actually write it as a lowercase c, and it doesn't actually matter, but for WebAssign purposes, make sure you use a capital C. We can say, for example, too, that the integral or antiderivative of 1 over x will give you natural log x plus capital C. And we could say that the integral or antiderivative of cosine x will give you sine x plus c. And again, that plus c is just the constant that when you take the derivative, it goes to 0, so we might not know what it was. All right. So just like with derivatives, there are a bunch of rules for antiderivatives. And so we're going to start off with one of the most common ones that we've seen, which is the power rule. Okay, so there's a power rule for derivatives, and there's also, let's use a different color, blue, there is a power rule for integrals. So the power rule for derivatives, we know, is you have the power, you bring it down, and then you lose a power. Now, the power rule for integrals is, or antiderivatives, and let me just write that down actually, that an integral is another name for an antiderivative. Okay? But the power rule for integrals or antiderivatives is basically the opposite of the power rule for derivatives. So we have this power up here, but we're going to bring it down as 1 over that power plus 1 instead of minus 1. And then in the power we have n plus 1, not minus 1. Now, I tend to like this format of the formula, but there are some folks who say, let's just put that all as one fraction, and they like the second version. I would say either one in terms of an exam is fine with me. All right, let's try some examples. So, example 4, the integral or antiderivative of x to the 5th. So I see that I have a power, in this case, n equals 5. So I'm going to plug that into the power rule for the integrals. So I'll get 1 over 5 plus 1, x to the 5 plus 1, plus a capital C. And this 5 is the n value that I have here that I do plus 1 to. And so now we're just going to simplify it. So 1/6 x to the 6th plus c. That's the version that I tend to like, but some folks prefer it like this. X to the 6th over 6 plus c, and I would say either version is fine. All right. Let's try it with example 5 here. Now, before we take a look at 5, it might be useful, just like we did with derivatives, to rewrite it so we can see the power that's actually there. Okay? Now, we haven't done the calculus yet. We've only rewritten it. But now we can apply the power rule. 1 over 1/2 plus 1, x to the 1/2 plus 1 plus c. And now we simplify. 1 over 3/2 x to the 3/2 plus c, or 2/3 x to the 3/2 plus c. This is totally acceptable. Or 2 the square root of x cubed over 3 plus c. So both versions are okay. All right. Example number 6, another one that I would suggest rewriting. So you'll notice here that there is a 7 in the front, and we can actually pull that out in front of the whole thing as a constant. Just like we had that constant multiple rule for derivatives, we have the same thing for integrals. And I would take this one step further. I'd write it as 7 times the integral of x to the negative 5 dx. Now, the reason why I'm doing that is so that I can actually use the power rule now. I know that my n is negative 5. So this will equal 7. I'm going to multiply it by the whole thing here. 1 over negative 5 plus 1, x to the negative 5 plus 1. And we'll put that plus c on the outside. All right, let's clean this up. 7, 1 over negative 4, x to the negative 4 plus c. But we would probably write this as negative 7 over 4x to the negative 4th, or negative 7 over 4x to the 4th plus c. And both of those would be acceptable. All right. So it turns out that with indefinite integrals, we can go ahead and add and subtract and do constant multiples the same way we did with derivatives. Okay, so those rules still apply. All right, let's take a look at this last kind of problem, which is an initial value problem. Okay? So we're going to approach this really similarly. First, we're going to find the antiderivative. And when we do that, we'll get dy equals sine x dx. So kind of like differentials. Now I'm going to integrate both sides. On the left-hand side, I will get y. On the right-hand side, I will get negative cosine x plus c. Now, in order to finish this problem, we actually need to find a number for c. And to do that, we're going to use these initial conditions. So we're going to plug in 5 for the y equals negative cosine 0 plus c. So 5 equals negative 1 plus c, or c equals 6. And then we're going to write our final answer as y equals negative cosine x plus 6. All right, so folks, if you look like this dog looks, then I would definitely recommend that you try some of the practice. The handout and answer key are available on Canvas. And I also will include a link to the table of common derivatives and integrals to help you get started. All right, if you have any questions, let me know, and I'll talk to you soon. Bye.